This video is titled Variables and Decision Logic Revisited. In this video, we will explore additional modeling options for decision path logic. To begin with, we will create a new version of our model by right-clicking on the previous version, selecting Copy Mission, and then right-clicking on Operations Models and selecting Paste Mission. We're then going to double-click on this new model, and we're going to update our description. As you may recall from the previous video on using variables for decision logic, we had looked at the enter pin and authorize pin portions of this particular system and tried to examine how we would capture that the person could enter their pin multiple times, up to 3 times before being ejected by the system. And we wanted to be able to evaluate whether or not to allow them to enter the pin again or to go ahead and withdraw them out if the pin was correct. For this particular video, we're going to look at the second portion of the model where they're checking the balance and either the person has entered in an amount to withdraw that was sufficient or they entered an amount that was insufficient. Recall, if they enter an amount that is sufficient, then what we want to happen is that the system will check the balance, find that it is sufficient, and debit the account and allow the person to take money from the slot. However, if it's not sufficient, then we want the system to realize that it's not sufficient and to show them what the balance is and then to go ahead and eject their card. Now, for this particular node, we can choose to make it either multiple, tactical, or probabilistic. And there are certain criteria that lean towards all 3 of those different options. So first of all, the tactical, we know that it's either going to do one path or the other. It's either going to do the insufficient funds path or the sufficient funds path, but not both, which would incline you to make this a tactical node. However, with the sufficient funds path, there are multiple things that are going to happen afterwards. And so in order to capture that, that would suggest that we would need to make this a multiple. However, there are also probabilistic aspects to this model because we want to be able to capture the probability that this particular path, the insufficient funds path, is going to happen 10% of the time, and the other 90% of the time we're going to have this sufficient funds path. Of course, with a probabilistic node, I'm going to go ahead and go into this check balance and show you this. With a probabilistic path, you have to set values for each path. So if we were to have all 3 of those items leading directly from this check balance, that would then force us to assign a probability for each of these. So we wouldn't be able to allow both the debit account and the take money from slot to occur at the same time. There's 2 different ways that you can handle this. The first way to handle it is the way that I've already shown here. I've actually added in these 2 unnecessary additional nodes. I'm going to update the details on here. So if it's less than the amount, it would go this way. And of course I've got balance spelled wrong. All right, so we've got these 2 additional nodes, and that they're not really needed, but they allow us to capture that probabilistic aspect as well as that multiple aspect that's happening. So here we can now set this to be a probability that the amount is sufficient, right, to be 90%, and insufficient, which is when it's less than the amount, 10% of the time. Right, so now we have a probability it's only going to do one of these 2 routes and not both, but then if it does do this route, we have a multiple, so we're now going to be able to proceed along both of those paths. So this is one way to handle this path logic without using any variables. The other way that we could do this is we could actually create a variable that stores whether or not we have sufficient funds. So I'm going to do that now. I'm actually going to go in and create a new variable. this is going to be a Boolean variable that can default to false, so either there is or is not sufficient funds. At the beginning of this check balance, I am now going to go ahead and create a way to probabilistically determine whether or not we're going to have sufficient funds, and I can do this as a beginning effect. Alright, so we've got a beginning effect here that generates a random number between 0 and 1, and then 90% of that time that random number will be below 0.9, therefore the sufficient funds variable will be set to true, and then that other 10% of the time we will assign a false value to that sufficient funds variable. Go ahead and check our code here. No errors found, good. Alright, so now we've handled that probabilistic aspect as a beginning effect, so we no longer need to use that here as a decision path. And so I'm going to go ahead and actually eliminate these nodes because they're no longer necessary. Bring this down here, and we're now going to actually allow this one to connect to these three. We're going to keep it as a multiple because there is going to be an instance when there is sufficient funds that two things are going to happen simultaneously. So we'll go through now and we'll go into our paths. So the show balance is that 10% of the time when it's insufficient. So we'll go ahead and put that in here. Alright, so now our paths will check this sufficient funds variable, and if it is equal to false, we will go down the show balance path, and if it is equal to true, we'll debit the account and take money from the slot. So this now allows us to have a cleaner diagram without those artificial nodes that I had earlier in green that were just showing pass-throughs, and allows us to use the beginning effects to help handle some of that probabilities that we want to capture. And this is a great way throughout your model in various different situations to capture some of the probabilities that you might want to, other than having to create additional nodes just so that you can capture those decision logic from the end path. Alright, so in this particular video, we revisited variables and decision logic and explored another option and helped to complete out this particular task network.